APC's plasma improves pet food and treat formulas. Important additives and ingredients, plus water, are added to the meat mixture to obtain a homogeneous raw emulsion. Plasma is added last. The raw emulsion is chilled to 12 to 14 degrees Celsius. The final mixture is then transferred to the shaper, which allows us to produce ropes in the targeted size and form. These ropes will then undergo a cooking process. Ropes produced with plasma show low adhesiveness to the surface, high cohesiveness, and high springiness. Pet foods containing plasma are easier to slice with lower crumbling, helping to reduce product losses in the production process. Plasma's superior functionality helps create higher quality pet foods and treats.
Hello, welcome to all participants to the Pet Fair Southeast Asia virtual conference. My name is Javier Polo. I am the Vice President for Research and Development in APC. Today, I'm going to provide, it's a pleasure for me to provide a presentation about the use of spray-dried animal plasma as a functional and palatable protein ingredient for the wet and the dry pet food. Okay, I hope you are able now to see the presentation. And as I mentioned, I'm going to talk about the use of plasma in wet pet food. The first comment I want to make is spray-dried plasma can be used in all formats of wet pet food, in pate, in loaf, in chunks in gravy, in chunks in jelly, alu tray, pouch. All kind of wet pet food formats can use spray-dried plasma as a binder. And why? What is the advantage of spray-dried plasma in wet pet food? As I mentioned, it's a quality binder, probably is the best binder for the wet pet food. In addition of this, improve the palatability, improve the digestibility, and because spray-dried plasma contains a high level of protein, allow to formulate a recipe with high level of protein and reduce cereals and starch. What is the most interesting properties of plasma? Why is common in the wet pet food? First of all is the water holding capacity. All of us, we know that the wet pet food is a food that contains around 75–80% of water, but this water cannot be free, need to be inside the block, the pet food block, in the chunks or the pate or the loaf. Then the water holding capacity is the capacity to retain water when you heat the product at different temperature, and this is the property for spray-dried plasma. You can see that in spray-dried plasma, when you heat at 80 degrees, is the maximum water holding capacity, and basically keep this the same till 121 degrees. And this is very interesting because usually at 80 degrees is the temperature that the steam tunnels are working in the wet pet food. Then the steam tunnels are working in the range of 80 to 90 degrees, and this is the temperature that plasma have the higher water retention capacity. Another property is the gel strength, the texture. Plasma provides texture to the meat texture to the wet pet food. You need to know that plasma start to make a gel at 70 degrees, but the maximum gel is at 121 degrees, 135 degrees. And this is really important because this is the temperature that usually the wet pet food is sterilized during the retort. It's at 121 degrees 1 hour, 135 degrees half an hour, and this is the temperature that plasma provides the maximum texture. When I'm talking about a gel of plasma, it's like this. It's like this video. This video contains 80% water, 20% plasma. You can make it in your lab if you want. It's just plasma and water and sterilized at 121 degrees. And you can see all the water is inside the gel. There is no water going out. Okay. For example, when you compare with gluten, that is another binder that traditionally has been used in the wet pet food. In this case, you have 20% with gluten or 20% plasma and 80% water, and you sterilize at 121 degrees for 1 hour. You can see that the gel of plasma, all the water is inside. There is no water outside. In the case of the with gluten, there is a lot of water outside, a lot of crumbs, a lot of fines, and when you are pressing the with gluten, there is a lot of water going out. Obviously, what will happen if you, instead of 80% water, you put 90% water and 10% plasma or 10% with gluten? In the case of plasma, all the water, 90% of water, is retained by the plasma. Okay, all the water is inside. Obviously, you can expect what will happen with the with gluten. You already see here the water in the case of the with gluten. You can see a lot of crumbs when you are pressing the gel of the with gluten. There is a lot of water going out. Okay, it's a good binder, but have not the same level of not the same property than plasma. Another property for plasma is this emulsification capacity, and this is really important because the wet pet food recipe usually contains fat, contain between 9 to 14, 15% of fat, depending on the recipes. But this fat need to be inside the meat block, not outside, and you need to have a good emulsification of the fat, the water, and the protein. In the case of with gluten, you can see when you put 15 part of poultry fat, 15 part of water, and 1 part of with gluten, and you sterilize 121 degrees for 1 hour, you have a complete separation of the fat, the water, and the with gluten. In the case of plasma, you have a perfect emulsion. There is no separation of the water from the fat. Okay, perfect emulsion with plasma. Okay. In addition of this, plasma also have excellent slicing ability. This is really important for chunks or for pouch. There are few proteins that you can cut like this with a very clean cut. Why it is important to have a very clean cut? Because you need to reduce the crumbs. You need to reduce the fine. With plasma, you can do that. Without plasma, it's more difficult. The owner, the pet parent, who buy the food for their dogs or cats, they don't like to see that. Usually they correlate this with a bad quality. And maybe the rest of the ingredients have this similar quality, but with plasma you avoid that because you have a very clean cut. Let me share with all of you a video about a meat pilot plant. The interesting of this video is that provide a very good training about the wet pet food, how to make wet pet food, and what is the different areas of interest in the wet pet food. Okay.
At APC's meat pilot plant, we reproduce in a small scale the industry of wet pet food processes with the goal of testing different ingredients. This space allows us to work with our customers and improve their product's quality with different finishing, as chunks, pouches, sausages, pâtés, loaves. At the meat bowl chopper, frozen grounded raw materials are mixed with the different additives at maximum speed. After adding other ingredients like wheat, flour, salt, and water to obtain a homogeneous raw emulsion, plasma is added last. The blending process finishes when the raw emulsion reaches 12 to 14 degrees Celsius. Emulsion then is transferred to the stuffer to produce ropes using the shaper device, more adequate for the target CHUNCKS size and form. Ropes produced with plasma show low adhesiveness to the surface, high cohesiveness, and high springiness. The pet food containing plasma becomes easier for slicing with lower crumbling, helping to reduce product losses in the production process. We also do R&D testing for our customer and third parties. We offer the opportunity to produce and test multiple recipes, which are compared during the different production steps, and analyzing TPA, texture profile analysis, by a double compression cycle, which gives several measurable and comparable quality parameters as hardness, cohesiveness, and springiness, among others. apcproteins.com.
Enjoy the video, and let me now to compare spider plasma with other binders. This is just the hardness, okay? You can see the control without any binder, and then different binders, 2% alginate or 1 gram, or caseinate with gluten at 2, 4, 6%, egg white in liquid or egg white in powder, kappa carrageenan, 1.2%, 2% or 2% plasma. Plasma have the highest hardness compared with other binders, even compared with 6% with gluten or with egg white. Similar than kappa carrageenan, but the difference that kappa carrageenan, first of all, is more expensive. There is some concern about the use of kappa carrageenan, some healthy concern about the use of kappa carrageenan, and also kappa carrageenan not provide protein. Okay. When you compare with vegetal binders like cellulose or fava bean or pea protein, you can see that any of these vegetal binders can compare with plasma, even when you are putting 4% of this binder compared with 2% plasma. Plasma provide a higher texture, higher hardness. Okay. Another interesting point is the juiciness. Let me explain what means the juiciness. The juiciness is the capacity of the chunk to absorb part of the gravy. Why it is important this? Because when the animal eat the chunks, part of the gravy will be released, and then this is very well correlated with palatability. Then this is the cook-in parameter, is the capacity of the chunks to absorb part, not all, but part of the gravy. Okay. When we analyze this and compare with the control without binder, or compare with gluten, even 6%, 2% of plasma have the highest cooking capacity. And just the opposite, the cook out, the pellet, the fines in the gravy, you can see that plasma reduce the fines in the gravy compared with gluten. Okay. Also the palatability. I mentioned before that plasma improves the palatability in dogs, but especially in cats. These are two studies. The first study was comparing 2% with gluten versus 2% plasma, and the second study was comparing 3% with gluten versus 1% of plasma. In both cases, you can see the total intake plasma was statistically better, improved the palatability in cats, and also the first choice. Honestly, we were not surprised with the data, because at the end of the day, dogs and cats are true carnivores, and they prefer the meat tasting like the one provided by plasma. I want to introduce you some concept about different ways to use plasma. Is the development of the byproduct analogues or the standard. It's a new concept, okay? The reason for that is, as you know, there is a challenge in the pet food industry. The pet food manufacturers are experiencing very unprecedented situation, that is the lack of availability of animal byproduct and proteins. There is several reasons about that. One of the reasons is due to the COVID situation. The number of pets has been increased significantly in the last 2 years. Okay, then if there is more pets, there is more demand for pet food. But at the same time, the COVID situation has disrupted the meat industry, and then there is lack of animal byproduct, especially because, as you know, restaurant has been closed and there is less product available for the wet pet food. Okay, and this has created a very challenging situation for not only for the pet food manufacturers, also for the pet parents, because they are looking for finding a good quality product that offer not only nutrition, also health benefit. In fact, this is a news that was just 2 days ago in the Fox News about the pet food shortage in United States, for example. Okay, then what is the project? The project is, can we, for example, there is a shortage in beef byproduct, or the beef lamb, for example, and the question is, can we make a formula that can replace beef lamb? And the request for the formula was that when you put in a loaf recipe, the beef lamb analogues need to be visible. Okay. And obviously a lower price than the present beef lambs, because the price has increased significantly during this year. Basically, the concept is what we note in the food industry, no? That there is the vegetable burger, but here the concept is something similar. Is, can we make a beef lamb without beef lamb? What we can use other beef byproduct that will be available, collagen protein, for example, spider plasma, beef meat meal, fat, obviously. And maybe we can use spider cell to improve the color, and water. Okay, and doing this, you can see that this is a real exercise. This contains beef in the left side. These are chunks containing beef lamb. And in the right side, this is the same chunks containing the beef analog. You can see that the pieces of the beef lamb analog. Okay, interesting. This is another potential use of plasma to replace animal products that are not available. Or just another example is to develop a extender. If there is a lack of animal byproduct, and maybe with plasma you can extend the animal byproduct that is the viability is not very high in the market. For example, here we have the pork liver extender analog. The idea for this objective is to develop a formula containing partially pork liver. The pork liver should be the main recipe in the formula, but with addition of plasma, you can see that we can increase the availability of this pork liver without reducing the palatability. Remember that plasma have a very good palatability. Okay, then basically the final product should have similar functionality and palatability and similar price than pork liver or lower, but increase the availability by 60-65%. Again, we in this case, pork liver will be the main ingredient in the formula. We can use other animal byproducts more available in the market: spider plasma, pork meat meal, spray-dried red cells, and water. And for example, this is the results that we have. You have here in the top left the chance with the pork liver, and you have here, for example, two formulas with the pork liver extender. And when you are analyzing the hardness, it's basically the same. The cohesiveness is basically the same. The chewiness is exactly the same. The level of solids in the formulas is similar. Level of protein similar. Level of fat is similar. Okay. Then you can extend the use of animal byproduct, and that is not really available in the market. With this, at the end of the day, what is the opinion of the final user? I'm sorry, this is a homemade video, but the final customer is our pets. In this case, it's a cat that you put a control recipe. The animal is lucky, but at the end of the day, made the right decision of consuming plasma, because plasma again is very palatable. The conclusion, well, it's clear that we can develop animal byproduct analogues or extender with similar or better technological functionality than the byproduct that we want to replace or extend. The analogues are visual in the final product, as you remember in the beef lung analog. The analogues or the extenders are less subject to the large price change. The price this year has changed 3, 4, 5 times. And obviously these formulas are less subject to the price variation. The plasma protein in the analog or the extender blends provide high palatability for the final product. Hopefully you consider that the concept is interesting. Just less the concept in your wet pet food recipes. Okay. This is my last slide, and now my colleague Joy Campbell will talk about the use of plasma in dry pet food. I hope you enjoyed the presentation in the wet pet food, and if any of you have any question, just contact us. Thank you.
Hi, my name is Joy Campbell, and I'm the Senior Director of Research and Development at ABC. Today I'm going to talk with you today about the dry application part of the presentation, spray-dried animal plasma, an untapped, functional, and palatable protein ingredient for the wet and dry pet food. First of all, I'd like to start off with industry challenges. As we think about the challenges that we've experienced, COVID has disrupted the meat industry, causing shortages and supply issues. Many pet parents even are still concerned about the DCM and the plant proteins in pet foods. Along with this, high protein products often struggle to balance the calcium and phosphorus levels to have the space. So as we think about the problem, the raw material availability and the global protein shortage. The market situation is that pet food shortages are on the rise as supply chains are stressed by the COVID situation. There's a crumbling infrastructure and other supply chain issues are affecting the protein manufacturers. What this is rolling into is unprecedented decreases in availability of protein, plus rapidly increasing prices, which for pet food manufacturers is leading to manufacturing challenges. The other part of this is the demand. Some of the stats from the pet food in Europe is the market numbers are up. They're up a lot, and there's the dogs and cats, as you can see, the total numbers are continuing to rise. So the numbers are up 102 since 2017. The state of protein in the pet is still fat. The protein is still king. Pet parents are wanting high quality levels of quality proteins in their products. And also, more pet parents are requesting proteins be primarily from meats versus plants. And pet parents are reporting more and more issues with chicken allergies, perceived or real, and are asking for products without chicken. So with that, the other part of it that people are focusing on is sustainability. focusing on sustainability of both ingredients and the packaging. Co-products from the meat industry are sustainable. Plasma is one of these products that can help support brand sustainability initiatives. For real meat formulas, plasma is a high protein that can come from an animal source. It's a 75+% protein ingredient, and it allows formulators to increase overall protein with an ingredient that doesn't impact the yield, like high water meats or organs, etc. It's helping in these areas. So as we look at kind of the formulation benefits, we break it down as under 30% protein formulation you're going towards, 30 to 35% protein, and 35% plus protein. In all diets, it's going to help to extend the protein due to the shortages. It's helping extend that protein part. It's also boosting overall protein ranges. It's a high protein ingredient. Reduces protein costs from these high price meats if needed. It could also help with reducing the needs for plant proteins and be able to replace some of those plant proteins with an animal protein source. Reduces the ash. Calcium is a low ash product. Potentially can remove salt from the label, and also in palatability, which we'll talk about later on palatability versus plant proteins. With that said, as we think about the benefits of plasma and high protein foods, as I mentioned, it's allowing more room in the formula for other ingredients. And we're going to cover how well it works in the extruder, talk about the quality of the kibble, and then it can be cost neutral. So let's focus in on the manufacturing side first. Looking at plasma and use in feed technology, we've done extrusion runs where we've included plasma up to 5% of the diet. These are kibbles that are formulated to about 28% crude protein. And we didn't see many differences. Texture, averages durability was about 97.5, hardness was a 22.9, and then also the toughness was a measurement that we had of about 4,193. If we look at comparing it to other sources of protein, we're comparing to chicken meal, salmon, lamb, potato, pea protein, and then showing the different levels of plasma, either 2.5 or 5%. The salmon, lamb, potato, and pea protein were all included, replaced at 5% is what those levels were, and so you're replacing it pound for pound. The chicken meal was the base, but then replacing like a 5% of that if comparing to that. But essentially what we saw was no differences noted in kibble durability. So it's not affecting the processing and being very similar to all other protein sources, ranging from anywhere from 97 to 97.8% in durability. So I'd like you to think about plasma as a protein solution for you. The protein ingredient benefits, or the plasma benefits we talked about, is it's a high protein, low ash product. We're going to cover a little bit on the palatability with dogs and cats. It's label friendly. And also think about the benefits on the health side too. There's a lot of background on that. To highlight a little bit on the function, the biological function, I'd like to talk about digestibility. On the digestibility side, this is a paper that was published by Quigley et al. In 2004, and what we're looking at here is digestibility of the diet when plasma was added to both the premium and super premium diets. So we had one experiment, which we got control 1 and plasma 1, and we're looking at dry matter, crude protein, or fat digestibility. We see an increase in dry matter digestibility with experiment 1, which would be more of a premium. Experiment 2 of a super premium, still having an increase in dry matter digestibility. We see a bigger response in experiment 2, a 4.2% improvement in crude protein digestibility, and also in fat, seeing some improvements, numeric improvements in the digestibility. So again, more of a biological function and helping with the diets too. Along with that, we followed both the grams of feces, essentially the fecal output, and also the grams of feces per 5 days on a dry matter basis. So on an as-is basis, if you've got an improvement in digestibility, you're going to have a reduction in fecal output, which is what we see on an as-is basis with both experiment 1 and experiment 2, and the same also on a dry matter basis. So essentially what we saw was less stool output, which is improvement from the digestibility, and also firmer stools for the owner. I'd also like to focus now thinking about replacing other proteins. This is some work where not only, I mean, you can put it in the formula, it can formulate in, it helps with the ash size, it's a low ash product, but how does it affect palatability? That is the take home. Is it going to affect the overall outcome? So we did some tests where we're looking at it in dogs. First I'm going to cover is palatability. It was improved versus a pea protein, so a plant protein. It was neutral with a potato and chicken meal. But essentially what you have is an opportunity. The fact that it was even neutral is you can replace with other proteins that are maybe less desirable. So let's focus in on first a high protein diet. This was a very high protein diet. We're replacing the pea protein. So we had a high pea protein source. We're replacing a portion of the high pea protein with pork plasma. On the left side, we've got the intake ratio. We're looking at a dog trial. It was 20 dogs, 2-day trial. In the intake ratio, we see a numeric increase with the combination of the pea protein and pork plasma. And then on the right-hand side, we're looking at the choices, the percent number of days the dogs consumed more of that. And this is defined as a difference of 20 grams. When they were presented with bowl A versus bowl B, did they eat more than 20-gram difference between those? And what we see here is yes. With the addition of pork plasma with the pea protein, they did see an increase in choosing to eat more of that diet compared to the high pea protein versus having no choices. If we look into the next thing, now we're comparing beef plasma versus chicken meal. 5% chicken meal versus 5% being replaced to the chicken meal with 5% beef plasma. Intake ratio numerically was down a little bit, not big differences, but then again, if we look at the choices, numerically up a little bit of, again, eating more on the days that they chose to eat more of the beef plasma. Pretty much equal with the chicken meal, and again, no choices. We go into the pea protein. Here we see the same type of situation with the dog trial of 20 dogs. We see an increase in the intake ratio, and also seeing now an increase in the choice, choosing to eat more of the beef plasma diet versus the pea protein. Move into cats. Cats is another area. Again, you want to make sure that the diet is working. If you're including these proteins, how well does it work? One of the things that we looked at is replacing spray-dried liver protein inside the cat kibble. We're not putting it as a coating. It's essentially when spray-dried liver can be incorporated into the diet, it helps with palatability, but then how does plasma compare? Is it similar? Is it not? So that's one of the things we're looking at. And also we looked at different, on the cat diets, looking at different palatant levels. We saw that we could reduce some of them, but again, not recommending it as a palatant on the outside, but putting it inside the kibble and helping with the palatability. So this is kind of a summary of multiple studies that we've done. On the top left, we've got uncoated kibbles. We see an increase, a consumption ratio of 2.6 to 1 when comparing 2% plasma to 2% spray-dried poultry liver. We then, instead of just having uncoated kibbles, we put a premium digest on the outside, 3% on both of them. And again, we had a 1.14 to 1, still having a numeric increase in consumption with the plasma. On the bottom left, we see a 3% super premium digest put on both. And again, 2.5 to 1, seeing a nice increase in the palatability with plasma versus spray-dried liver. And finally, the last thing we did is taking the kibbles and saying, okay, let's put the control and have 3% of a super premium digest on the outside. But then with the plasma one, only putting on 1.5% of the plasma on the outside. And again, we are seeing we're able to reduce it. We still had a 2.7 to 1 increase in intake and being able to have a higher intake with the plasma diet versus spray-dried liver. This is the same study we looked at. We're looking at that intake ratio, but then also looking at the choice. And in the cats, the choice in this situation was a difference of 10 grams. So were they choosing, when they had the bowls A versus B in front of them, were they choosing to eat more of that diet? And here it's a very clear 70% of the time they were choosing to eat more of the diet with the 2% plasma versus the 2% poultry liver, and also even it was down around 10 to 12%, and then also when they couldn't make a choice, when they weren't eating a difference more than 10 grams. So again, a very clear picture of being able to show the reduction of the digest and yet still having a good palatability compared to 2% poultry liver. So in summary, plasma and pet food allows for more room in the formula for other ingredients. As we've seen, as we've talked about what's happening through the extrusion and the production, seeing similar durability, the texture, etc. So the kibbles are looking good. We're able to maintain the quality of the kibble, and then along with it, having good palatability. Seeing the palatability compared to plant proteins in dogs, having improvements there, and then also comparing in cats compared to the spray-dried poultry liver and having a nice improvements in palatability. So with that, I'd like to thank you for your time. If you have any questions, please feel free to reach out to us via our contacts in the conference. And thank you for the time to discuss with you today this plasma protein